Resilience of the bulk electric power system to survive black sky events is a priority for the electric sector and society as a whole. Recovering the bulk electric power system after such an event will require reliable communication, allowing the timely exchange of critical information. In the past, exercises testing the industry's ability to respond to and recover from black sky events have generally assumed that adequate communication capabilities will be functional and operational, but that may not always be the case. A resilient communications system connecting operators at remote control centers verbally is required to provide sufficient visibility of the grid's status. This resilient communications system is not intended to replicate the robust capabilities of a primary communications system, but needs to enable speedy grid restoration. The temporary system will need to survive the black sky event, interoperate with other communication systems, scale to the number of required communication points, be easy to deploy, and have well-defined maintenance, training, and testing requirements. The Electricity Subsector Coordinating Council prioritized this issue, establishing a resilient communications working group with the objective of a test-and-learn demonstration. To support the ESCC working group, the Electric Power Research Institute, EPRI, initiated a collaborative project with key members to test 4 different communication technologies, with an interoperability solution at 3 emergency control centers. The project explored various commercially available communication systems and interoperability solutions. The demonstration focused on enabling two-way voice communications between the project participants to emulate the initial restoration of the bulk electric power system, utilizing a range of communication technologies for improved redundancy and to allow for a diversity of vendors to choose from, and achieving interoperability between different communication technologies, including enabling multi-party conference calls. The demonstration tested the limits of commercially available communication technologies, connecting entities over cross-country distances of up to 900 miles. The control centers also communicated with substations, generators, and neighboring utilities using existing alternate communication systems. The demonstration culminated with operators at each of the testing sites using scripts to simulate a black start. The group held multi-party conference calls between the 3 main sites, using 4 communication technologies with differing levels of success. The control center operators also executed scripts with the generators, substations, and neighboring utilities. One of the control centers was also able to contact the Electricity Information Sharing and Analysis Center in Washington, D.C., using satellite communications. At the conclusion of the demonstration, EPRI evaluated and documented the performance of each resilient communications technology and the interoperability between them. Key findings included a network of geosynchronous satellite links created an effective backbone for reliable voice communications between the 3 distant control centers. An HF radio network involving remote base stations and a network operations center connected pairs of control centers. However, a 3-way conference call between the control centers was not established. The low Earth orbiting satellite systems had mixed results. Their interoperability challenges may be addressed in the future. The interoperability solution was effective at bridging a variety of communications technologies. To avoid a system configuration that relies on commercial telecommunications systems and the Internet, neither of which may be functional after a black sky event, the design and execution are paramount. 3 weeks after the demonstration concluded, Southern Company and NYPA successfully communicated through the Resilient Communications System in the Grid X5 exercise. The successful demonstration showed the potential of commercially available resilient communication technologies and highlighted areas requiring further development. The detailed results of the demonstration are available from www.epri.com in report number 300-201-7908. Looking to the future, the ESCC Resilient Communications Working Group is considering a longer-term pilot implementation of multiple interoperable resilient communication technologies over a wide region. Related EPRI research in this area can be obtained by downloading the Resilient Communications Selection and Design White Paper, ID 300-201-8702. Also, currently underway is the EMP for Telecom Supplemental Project that is investigating the potential impacts of Hemp E1 on communication systems that are utilized by the BES. And if potential impacts are found, will identify and evaluate potential options for mitigating the identified impacts.